Hey guys, it's time to talk about cross-site scripting. That's a web-based attack that it is exploiting in the client side. The difference with other attacks is that the browser is going to be executing the malicious input being injected by the attacker. It is a well-known vulnerability. It has been, for many years, one of the top 10 vulnerabilities in the world. A real scenario about this is, let me explain you how it works. Let's suppose that you have an email that is saying, please click on this specific link. We all know that we should not click on those links, right? Because probably it's a link that can be malicious. When we go to that link, we might be infected. So nowadays, we are kind of conscious about those things, and we don't click on those malicious links in order to prevent from being infected. With cross-site scripting, an attacker can force you to visit that link without your knowledge, and therefore get infected. That's the reason it is a very important vulnerability to learn about. We're going to talk about this vulnerability and obviously how we can protect our organization. My name is Daniel Regalado. I am the lead author of Grey Hat Hacking Book 4th edition and hope you enjoy this course. The agenda, we're going to talk about the overview about cross-site scripting, the types of cross-site scripting that we know about, mitigation techniques or strategies so that we can protect our organization. Overview. So what is cross-site scripting? It's a vulnerability to inject client-side scripts into the web page. Well, what is client-side? Client-side in this context means your browser. Scripts, we mean JavaScript or Visual Basic script. Those ones are executed always in the browser and are supported by all our operating systems. Examples, Chrome, Internet Explorer, Opera, Safari. Common targets, honestly, any specific input in your web application might be vulnerable. I'm going to teach you how you can find them. But can be login pages, can be contact forms, can be search engines, user profile forms, any input, as I said. So let's talk about the reflected cross-site scripting. That's the first one, very common. So how that works? So here is the scenario. We have a box in our web application where we're about to search for an item, any item, okay? So let's say that we put books in order to search for this item in the database. When we get the response, it says, hey, the item books was found 300 times. What you are seeing here is what we put in the input, which was books, it was pasted back in the response. In that scenario is where we say we have a potential cross-site scripting. Keep in mind that if I send something and that content is pasted back in the response, it's a potential cross-site scripting, like in this case. If we might see the source code of this, we can see that behind the scenes it says the item books was found 300 times. The result, the input was pasted in the output, okay? So let's see something malicious. Let's say that apart from books, we also insert double quotes, and then a script block, in this case, to redirect to a hacker site. When we send this search, the application is going to respond saying, hey, the item books plus the scripting block was found 300 times. What we are seeing here is that the attacker sent a JavaScript code which was sent back in the response, and therefore the browser is going to execute that JavaScript. What the attacker is going to do here is going to send that specific link to the user so that the user, when they click on it, it will execute this location.href and it's going to redirect the end user to the malicious site. That's called reflected. We send it and right away we receive it back in the response. If the content sent to a website is pasted back into the browser, it is a cross-site scripting candidate, as we saw. Let's see the other one, store cross-site scripting. Well, the main difference between those is that the same injection that we sent is not pasted in the response as we saw, but it is saved in the database commonly. That means that we inject only one time. We can leave it there. Let's say there is a section which says show the latest news, and the attacker find a way to inject the malicious code in the new news of the website. It is stored in the database. Every time a user wants to go to that website and click on see the latest news, that specific injection is going to be retrieved from the database and loaded, sending it back to the victim, which is going to execute it in the browser. As you can see, the main difference, the execution is the same, but the difference is instead of being reflected, it is stored in the database, and every single person visiting that specific section of the website is going to get infected. And therefore, store cross-site scripting, every user visiting the infected site is attacked, as long as they visit that portion of the site where the injection was stored. Let's see some attack scenarios. Session hijacking. That means we can steal cookies. As you know, every time you connect to a website and you authenticate into it, you get a session cookie 90% of the time. You get a session cookie, which is authenticated, and if by any chance someone grabs that session cookie, they can put it in the browser, in their own browser, and impersonate your accessing whatever application you were logged in, banking account, whatever it is. So the attacker can do something like this. They can prepare in their website. They need to find a way to lure you to connect to their website. When you go to that website, probably can be a blog teaching you how to cook, a blog teaching you how to buy soccer, tennis. As long as you go to that website, he's going to load the iframe. This iframe is invisible. You can see the height and width is 0, 0. That means it's not going to be shown into the web page, but behind the scenes, the iframe is going to connect to the hacker site, and the document.cookie is going to be sent as part of the content. That means that if you are in a banking session and you try to visit in the same browser that specific website, it is going to steal your cookie and it's going to send it to the attacker. At that point, the attacker can use your cookie and impersonate your access. This is another example that you can also put it in an image. So the attacker is saying, okay, here is my image, and the image is going to connect back to the attacker's website. Again, connecting to HackU and concatenating the document.cookie. Keep in mind that this specific injection is in your browser, in the victim. We are accessing that specific page, and it is redirecting us. Our browser is executing those attacks. And therefore, our browser is the one who has the cookies, and those are being stolen. I'm going to talk about also the same origin policy in a second, because that's another very important topic that we need to discuss. Okay, here is another attack, browser redirection. As I said, the attacker can put an iframe, and instead of stealing your cookies, he's going to say, connect to my website. Your browser is going to connect to the hacker website without even knowing it. And if the hacker has an exploit that can compromise your browser, they will get access to your PC, or they can infect it, which is pretty common, by the way. Other kind of attacks, browser exploitation. There is something called the universal cross-site scripting. Nowadays, there has been a lot of news about this kind of attack using cross-site scripting or cross-site request 480, which is another course, where universal cross-site scripting means that unlike the common cross-site scripting attacks, XSS, which is the name, is an attack that exploits client-side vulnerabilities in the browser. With cross-site scripting, as you remember, we are just executing JavaScript code, right? But in this kind of attacks, the attackers are exploiting vulnerabilities in the browser or in the plugins installed on that specific browser. Once they exploit this vulnerability, obviously there is a connection with cross-site. That's the reason it's called universal cross-site, because that vulnerability in the browser, they will use cross-site scripting attacks to trigger those specific vulnerabilities. Can be JavaScript code that can crash the browser or gain code execution. That's very common, and we have a lab about universal cross-site scripting with a recent vulnerability that attackers can be able to bypass security controls. Actually, that vulnerability that I was just describing is able to bypass what it is called same origin policy. When we talk about browsers and websites, there is a concept known as same origin policy. That means, let me explain you a scenario. Let's suppose that you have your session in a bank, online banking, right? Here is your web page, and let's suppose that you open a second window, and then you navigate to a blog. But that blog, let's say that it is malicious, and there is an attacker there trying to exploit your PC. The attacker is able, if the attacker is able to exploit your PC, still the same origin policy protects you, because the attacker cannot go from that website and read everything in your banking page. In other words, the attacker, even though if it compromised via JavaScript or cross-site script in your browser, he cannot go and say, okay, let me connect to the banking page and grab cookies and grab everything. Reading remotely is not possible. That's what same origin comes into place. In other words, what it says is only from the same origin can be able to read information from. If you are in a different origin, which means origin means same protocol, same port, and same host. If you are in a different host, different domain protocol, or different host, then you are not in the same origin, and then you are not allowed to read from that other website. Let's see some examples here taken from Wikipedia. Let's say that we have this specific URL. If we try to validate the same origin against this URL, we can see that the first one is success because it is the same protocol, HTTP, it is the same host, www.example.com, and it is the same port, 80. The second one is exactly the same. We can see that the second one even have a different URI. It is other instead of page, but it is the same protocol, same host, and same port. These 3 points are the ones that decide if it is the same origin. The third one is the same, but the fourth one is a failure. And the reason it is a failure is because you can see that the port is 81. Since it is the port 81, and the original that we are comparing is port 80, then it's not the same origin. Same for the next one is a different host. You can see that in that one is en.example.com, and our main URL is www.example.com. It's the same domain, but different subdomain, and just because of that, it's not the same host, and it's not the same origin. And well, there are other examples. Internet Explorer, they don't rely on the port, they rely on zones. It's a kind of different approach, but similar idea. As you can see here, same origin plays a key role in this whole web-based environment. So that, as I told you, attackers cannot just grab your browser, execute JavaScript code, and start reading the whole content of your sessions in your machine. They cannot do that because of the same origin policy. Unfortunately, the attackers find ways to bypass this control, as we are going to see in one of our labs, how they can bypass same origin policy via a universal cross-site scripting attack. Mitigation strategies. How we can prevent cross-site scripting. Input validation, as usual. If you get garbage in, garbage out, right? So input validation, whitelist approach. That means don't try to block every single attack. You better say, I'm just going to receive this specific type of information, or even this specific list of input, nothing else. Can be alphanumeric, can be numeric, but only that, as I said, by type, by size, can be only 10 characters, 20 characters, is very important. Output HTML coding for cross-site scripting is even the must-have. You might miss input validation, but cross-site scripting is executed in the browser. That means every time you are writing something back to the browser, you need to do HTML encoding. What I mean is this: instead of putting cruise script, you have some APIs that will transform the less than and greater than into the HTML representation, which means the browser is not going to execute it as JavaScript code, but just as a string in the response. Recommended to use ESAPI, which is an API from OWASP, which supports multiple languages so that you can implement this solution across your different flavors. This is just an example of how you can implement it, and as usual, you can follow our labs to see this in great detail. Some APIs for you guys, some URL for you to visit it. And another suggestions, HTTP only cookie flag. That's a flag in the cookie. If you put it, the attacker cannot read your cookies via document.cookie. As you remember, the attacker was injecting an iframe with the document.cookie and is able to steal it. If we put this flag, JavaScript cannot read your document cookies. It's that easy, and that's the recommendation. Content security policy, very recommended. The guys from Chrome come up with this solution, and it's basically a set of headers that the server sends to the browser in order to say, hey, you need to comply with this in order to interact with other pages. Basically, it will protect your it will leverage the same origin policy. It can say something like this example. You know, the content security policy, it said you will connect to the default source, which is self, and the scripts can be loaded from self, which is the same origin, or the mysite.com. It's saying you can allow everything and scripts from the same origin and from mysite.com only, nothing else. You can control via HTTP headers the same origin policy, which means even if the attacker is able to bypass the browser implementation of the same origin, you still have this CSP policy to help you. For end users, you guys can use different plugins. I highly recommend NoScript from Firefox, which prevents most of the cross-site scripting attacks. Or if you're using Chrome, you can use ScriptSafe or uMatrix, which are other recommended ones too. Some references, definitely, OWASP. Go to the cross-site scripting prevention sheet, which is very good for you guys to understand all the different techniques. CSP, if you want to learn more about it, it is there. Okay, guys, so just to summarizing, cross-site scripting is a high-risk vulnerability. You know why by this time. Easy to exploit and with a high impact to the organization. A PC from the organization can be forced to visit a specific URL, which can exploit your browser and get access right into your network. But it's also easy to prevent. It's a well-known attack and a well-known solution. Multiple mitigation techniques available. Another thing that we need to mention is that the browsers comes with built-in protection from cross-site, so make sure to not disable it. And if you can use CSP, as described, to help you to enforce the same origin and prevent other attacks. Secure code review is always recommended for you to find problems in your web applications, and penetration testing once it is in production. Hope you like it. Welcome to the cross-site scripting lab. So, as usual guys, we're going to have multiple exercises here so that you can fully understand this specific vulnerability. Just a quick reminder, since you already attend our slides class with all the details about this vulnerability. So, cross-site scripting, also called XSS, it is a web-based attack, okay? And it is called client-side attack. Why? Because it is executed in the browser. That means it is not affecting the web server. Every time you hear about a cross-site scripting vulnerability found in, let's say, WordPress software, that means that something happens in the browser while visiting WordPress. That doesn't mean that someone compromised the web server. Now, there are two types of cross-site scripting. One is called reflected cross-site scripting or non-persistent, and the second one is called stored cross-site scripting. Simple explanation: stored cross-site scripting means anything that the attacker is sending, obviously malicious, is going to be stored normally into the database web server. And that means that every time the end users visit that specific section, the malicious content is going to be loaded. It doesn't matter if you are connected and then you log off of the application. Since it is already in the database, it's going to be loaded every time you visit it. Obviously, this is the most dangerous scenario for a cross-site scripting vulnerability.
The second option is reflected. Reflected means that the attacker must put malicious information into the URL, and only the persons clicking exactly the same URL with that malicious content will be affected. What are the consequences of cross-site scripting? Well, basically, the attacker can execute JavaScript, Visual Script, or HTML, which are usually the most common languages being executed in the browsers, and they can redirect your browser to their own website so that they can infect your machine, well, try to infect your machine. They can also steal your cookies so that they can connect to your bank or any other application that you are using locally in your machine, so they can impersonate legit users. They can also load phishing websites by adding their own HTML code. And just so that you know, we have a pretty cool demo about cross-site scripting, a real-world vulnerability in a WordPress plugin. Check it out in our case studies so that you can see from a penetration testing point of view what you can do. Okay, so back to our lab. We're going to be talking about the process as a security code reviewers, how we can hunt and find these vulnerabilities in the source code manually. We can also use scans, and that's going to be another lab, but it's very important for you guys to understand how to find these bugs just by looking through the source code. Then we're going to talk about how we can verify that the bug is real, gather all the evidence, and finally prepare the report to be presented to the stakeholders, business owners, and developers. So let's start with our first example. We have the path in our lab, which is under the web server, which is commonly found in Kali. This is a Kali system, normally used for penetration testers, pretty useful. And we are in the path /var/www/CSTT, which is our academy name, cybersecurity think tank, and the folder XSS. XSS is also an abbreviation of cross-site scripting. So let's open our first exercise. In this first exercise, as usual, we need to identify the entry points. You remember the threat modeling class. We need to find all the entry points which can affect the behavior of our application. We can see here that there is a parameter called data being received via get parameter in the query string. We'll see that in the browser. And that parameter is going to be copied inside a JavaScript block into an A variable, and then that variable is going to be pasted into an HTML element called text area. As you can see, the input received is being copied into the HTML response. Cross-site scripting is executed in the browser. When you see input being pasted back into the HTML code being sent to the browser, that's a clue for a cross-site scripting related issue. Since here we don't have any input validation, because we can see the input is in get data and we don't see any filter, that's a red flag for us as a security code reviewer that there might be a cross-site scripting problem. As usual, now that we understood the source code, we need to replicate and to run this script so that we can have a better understanding. We are using PHP here, but the same concepts are applicable to other languages. So we pass the the question mark signed so that we can pass a parameter. In this case is the data get parameter and the value, the content. Every time you pass a get parameter must be after the URL, as you can see here. So we hit enter and we can see that, as expected, the input that we enter is being copied back into the response into our text area element. We can, change it to any other value. So this is the normal behavior, and then we can see that, as we saw in the source code, there is no input validation, and then we mark down this specific script as a potential cross-site scripting. Let's move to the next exercise. So we go to this option 2, which is called normalizer. Again, we can see that it receives a data argument, but now via post request. Post request is a different HTTP request that it is sent normally through forms, HTML forms. But we can see here that the content of that entry point is being sent through something, which I can tell you right away it is an input validation, and eventually the content received is going to be changed into something more secure. That means we have a filter. Keep in mind that you don't need to know all those functions. Every time you find a function in the code review, it's always recommended to go and understand exactly what that function is doing. Here we can see that all the content received is going to be filtered out. And let's go quickly to this specific function. This function, as we can see here, is going to transform all the input into these specific values. If it receives an ampersand, it's going to be changed into the HTML entity. It is called HTML entity, which basically is the same representation of that specific value, but without being treated as an HTML code or JavaScript code, because it's dangerous. Okay, they can also use double quotes. If we found double quotes, they change it to the HTML representation, HTML entity. The same for single quotes, less than and greater than. So those are the most common characters being used by attackers when trying to execute cross-site scripting attacks. So that's the main reason that this specific function, it is filtering them in order to change their context, and they can be transformed into something that cannot be executed. And there are a couple of options. We can see that we saw in our source code some specific options, which is this end quotes. That's very important to be set, because that's gonna also include the single quote and double quote conversion. If you don't put that flag, that means it won't protect against attackers sending single quotes or double quotes chars, which can be used for cross-site scripting. So those are the basics of this function. Then we can see that there is something called normalize. That's something that, let's assume at this point that we don't know what it is. We have multiple lines of code to analyze, so we need to move fast. We need to mark down the potential vulnerabilities, and then in the next phase we will validate them. So here we can see that it is some kind of input validation. So we are going to run this specific script and see how that works. So we run normalizer, and this is I forgot to mention that, guys, sorry, it is in the source code, but we can see it here. it is a typical scenario where it is a search value that you have a box, and whatever you enter to search, it's gonna receive the response saying, oh, the search for, in this case, Danux has been found n times. In cross-site scripting, since we know that it is going to be affected the browser, we need to concentrate our efforts into find sections in the application where the input sent is pasted back in the response. The best known scenarios are search engines, as we can see here, and contact forms. You remember when you are filling out a contact form and you are ready to submit it and you miss to put the right phone number. After you click submit, what's going to happen? It's going to put an error message saying, hey, the phone number is not in the proper format. But that means that well, it depends on the application, but most of the applications send the request to the server and come back saying, hey, you know what, this is not a valid phone number, or this is not a valid credit card, or those kind of things. But the content that you filled out in the form was sent and received and pasted back into the response. That means the attacker can say, oh, whatever I sent is received again, then I'm going to start injecting malicious JavaScript or HTML. So that's very important when hunting cross-site scripting, to look for places where our input is pasted back in the response. So in this scenario, if we can try to put malicious information, in order for us to send post request, since the post cannot be sent here, as we saw with the get request, the get request variables can be sent here as part of the URL, but the post request needs to be sent in a different way. We need to use something called a proxy. We have multiple proxies, but here with this browser, which is Firefox, we can use a really cool plugin which is called Temper Data. Temper Data, you can just search for it in Google, you will find it. Temper Data can allow us to intercept packages on the fly. So we set start tamper, and then we click here on submit, click tamper, and you can see that the data input field, we can put something different. Obviously in this case, since we are not using this maliciously, it is exactly the same that if we put something here like something like that, we stop the tamper, we can see that the response was sent back. This feature is important for us in the verification phase, but right now we are not injecting anything malicious. So you can see here that if we inject a single quote, let's say, because we are going to try to find vulnerabilities, if we click, we can see that the representation is exactly as expected, Danux and a single quote. But if we look at the source code, we can see here that we have this value normalized. Let me check it quickly. Yeah, okay, so then we can see that if we inject something like this and we go to the source code, we can see that the source code, there is a less than. That means our less than sign was changed to what we call the HTML entity, which means visually is going to be presented, but behind the scenes is not going to be put as a less than, because can be used, as you can see, HTML use the less sign as part of its code of execution. So this is saying I'm not treating it as a part of HTML code, because you can use it maliciously. Let me try another check here, and you can see that I don't know why, for some reason, in the previous example, the single quote was not transformed. But well, here it's been transformed. Also, the single quote has been transformed to the HTML entity representation. Again, you can see it here visually is the same, but behind the scenes is different. Let's try, obviously, other characters like quotes that we know is going to be filtered out, and the ampersand. We click on it. Again, the visual representation is the same, but behind the scenes it is transforming everything so that it cannot be treated as HTML code in this case. Okay, so in this scenario we can see that looks like there is a proper validation of the input received so that we cannot inject malicious things. But let's assume, as I said, that we don't know anything about this function. What we can see here is that just after copying the response back to the browser right here, there is some processing here that we don't know what it is. Ideally, you should put the output validation right after copying the content back to the browser. But here it looks like there is a process in the middle that probably might change the content and could be exploited by an attacker. That means we cannot say here that this is safe from cross-site scripting. We just mark it down for us to verify it manually in the next phase. Now that we understood the steps of security as a security code reviewer, how to find cross-site scripting, it's time for us to validate if those are real vulnerabilities. So let's move on to our first example. So here, as you remember, we have a clear input, no validation in the output. So let's test it quickly in our browser. So here, if we start playing with this, again, this is not a penetration testing lab. That's a totally different cybersecurity certification. But we need to be able to understand how it works in order for us to find the vulnerability and know how to fix it. So let's say that here, if we see the source code, we can see that it is being copied into the text area. If we put here like a single quote, and keep in mind something very interesting here, the content is being copied into the JavaScript block. As you remember, we are inside a JavaScript block, and here is where our content is being pasted first, right? So we can try to put here a single quote, finish our JavaScript instruction, and then execute something like an alert. Hello there. An alert is usually very common to use for cross-site scripting validation, because then that is telling us that the JavaScript is being executed, and that can help us to confirm that it is a true vulnerability. And then we're gonna say, okay, let's close this block. When we execute it, we can see that we got a pop-up. Every time you deal with cross-site scripting and you get a pop-up, that means vulnerability confirmed. If we check in the background, you can see that what we did was we input the hello. This first single quote was already there in our source code. We input the hello, we use the single quote right here, then the semicolon, our alert, and then we close the script. Basically what we were doing here is we inject our own JavaScript code. Okay, I mean, again, this is not a penetration testing lab, but just wanna explain you the reason this is being executed, and therefore it is a true vulnerability. So we just confirm that we found our first cross-site. Let's go to the second example, to the normalizer. In normalizer, as we remember, if we try to put something like Linux and I don't know, let's say let me check. It's very useful to check the source code. If we are gonna try to inject something here, it's gonna be in this value. No, sorry, it's not gonna be there. Anyways, it's very important for us to check the source code and the HTML source code to see what we can do. So if we put Linux and then let's say that we say, okay, so let's say script alert 111, and you know, this is the classical test for cross-site scripting. So we do it, we said that we didn't get our pop-up, right? That's our final expected result to confirm it is vulnerable. So we didn't get it. Let's check the source code of the page, and we can see that we have an input validation in place. And actually, that specific validation, it can also be treated as output verification validation. So we can see here that less than, greater than, less than, greater than, those were properly filtered and transformed into HTML entities. That means we can see it visually looking good, the same, but behind the scenes, those are not being executed as JavaScript code. Okay, so here is where normalization comes into play. Let me show you. So if we remember when we saw our lab, we have this normalized. So it's time for us to dig more about this thing. So we saw that at this step, everything is properly transformed and we are not able to execute anything. And then at this stage, normalization is doing something. Normalize means this is a specific feature called Unicode normalization. Basically, what that means is this. When you have, let's take this ACE as an example. You can have here, as you can say in the UTF table, this is the Unicode representation. In the table, you can see that those are Latin capital letters. Okay, but they are like grave, acute, I mean, different options. But as you can see, they kind of look similar. I mean, the visual representation is similar. What normalization is going to do is going to say, okay, so all of those that look similar, I'm going to transform them, which is called normalize them, into the same X binary representation. That means that if someone entered either this guy or this guy or this guy or this guy, any of those that are similar, I'm gonna put behind the scenes the same binary representation. Why you wanna do that? Think about a search engine that they wanna search for specific charts, so they don't care about those differences. As long as look like a Latin capital letter, they are gonna try to find capital letters, right? That's one option. Another option is that if you want to be consistent with the names, let's say that the names follow these properties. You might have names with this A or names with this A. So if you want to be consistent, you don't care about those differences, and then you save it with the same X representation. That's the idea behind normalization. But unfortunately, that can also be used maliciously by the attackers. Let's see this example. We have here the less than. As you remember, that was being properly handled by our filter in the PHP script. But this guy, the visualization is very similar to the less sign, but this is called full with less than sign. That means that this is not the one that we always use in our alphabet, in our keyboard. The normal hexadecimal value of a less sign is 003C for Unicode or 3C hexadecimal. But for this specific one, we can see that the representation is EFBC9C. So let's see what's gonna happen if we here in our input insert that specific value. So again, we're gonna be using our tamper data in order for us to intercept the request and can be able to inject those specific hexadecimal values. So we click submit, we get this prompt, we say tamper to be able to change the content, and here we're gonna paste our hexadecimal value representing the full width less than sign. We do it this way so that it can be interpreted by the web server. We save this value and then we click OK. I will stop this one. So you can see that in the response we get the less than sign, right? Let's check behind the scenes. It is properly transformed into less than sign. Now, sorry, some mistakes with the browser, but now I get it right. Yeah, now I get it as expected. I was scared, but hope it is working. So I don't know what happened before, but if we see the HTML source code, we can see in red that it was not transformed with the less than sign as we saw before, right? So that means, if you remember, that means that due to the normalization, we enter, let me just quickly close this, due to the normalization, we enter something that was not understood, and let me explain you this here. What happened is right this. We have here our first layer. We sent the less than sign, but we know that this guy is not the one that we use in our keyboard. The filter at this stage says, okay, are you guy the one that I know in the keyboard? And it says no, because you are something, let's put this so that we can just make the difference. Oh, because you are this guy, you are not a less than sign that I know. So I don't know what to do with you. I just let it get in without any filtering. When this guy get to the second phase, here is the normalization phase. The normalization says, hey, I know this Unicode value. This Unicode value, due to normalization, I'm gonna send it and normalize into a less than character. Finally, this value is the one that we see in the browser. Now, we can confirm this, right? If what we are saying is true, that means that we can get our pop-up alert. Let's try to do that. So we click submit, we click tamper, and here we're gonna say, okay, if you remember, this combination was the less than sign. We put it in that way, and then we say script. Then we need to use the greater than sign, but keep in mind that that one is gonna be filtered out, right? So instead of that one, we use the same technique, but instead of 9C at the end, this is 9E. Okay, it is a full width greater than sign. Then we put our alert, and then we need after the alert to close the script block, which is with the less sign again. That's the less sign, the slash, and finally the script tag and the greater than sign. So basically we're putting our chunk of JavaScript here. When click OK, see that we got our pop-up. That means we find a way that this specific application is vulnerable to cross-site scripting due to normalization. Let me just stop the tamper. So if we go here to the source code of the page, we can see that everything was exactly transformed as expected, and therefore JavaScript is executing in the browser and we got the cross-site scripting identified. So now we can see that we were about to discard this vulnerability, but because we dig into the normalization scenario, understood how that works, we were able to see and confirm that it is a cross-site scripting vulnerability. Now that we understood how to find cross-site scripting and how to verify that those are real vulnerabilities, we are ready to come up with our countermeasures or mitigation techniques report. So let's talk about our first example again. We go to the folder one, and then here we're gonna use the secure version of our script. So basically what we are doing is, let me open it, is this one. So see, what we are gonna do here is this. As you remember, we don't have any input validation right there, right? So what we are gonna do is, let me open the secure version. So we're gonna use HTML special charge entity in order to validate this specific input. We copy it, we close it, and then here instead of just receiving the input, we're gonna say, hey, pass it through the input validation. Now we are adding end quotes, which says also protect against single quote and double quotes, and it's recommended to add also the end substitute. This basically means if you have invalid unit points, which is related to Unicode strings, also send a blank response. That means that if someone is trying to play with Unicode attacks, it's gonna help us. So we have this value, and then we are ready to test if the solution works. So we go back to the one, it's still working. It's still working. And then if we start putting here something as we remember this guy, and then semicolon, and you know, the alert, blah blah blah, you know, just replicating our first attack, we can see that now we didn't get the pop-up because it was properly validated. In other words, our recommendation for cross-site scripting is, in this scenario, to use this specific function, which is going to help us in order to protect the response being sent and not treat the content as JavaScript code. Let's go to the second one. I'm gonna use this guy. So in the second one, let me what we are doing here is this. First of all, the order, and I'm gonna open right now the vulnerable options so that we can see the difference. So at the top is the vulnerable version. You remember we have a proper input validation, but after the proper input validation there was a normalization process which was maliced by the attacker and gave us vulnerable cross-site scripting. In the bottom of the page we can see the proposal. In the proposal, you see the difference? The difference is just do anything you want to do with the content. Normalization, transformation, anything you want. When you are ready to copy this content back to the response, the last step in the chain is where you need to put your validation. In this case, your output HTML encoding. Because as you can see, after this step, the letter B is copied in the response. So that's the recommendation. You can see here that there was security controls in place, but the way the design of this specific page was improper. Again, we can obviously validate that this is working fine. So we go to sec, and here let's open our tamper data again. We click submit and tamper to intercept it, and then here what I'm gonna do here is I'm just gonna copy quickly. Let me grab the content of this guy again. I'm just gonna quickly test that this is not working anymore. So I'm gonna put here percentage, and this guy, if you remember, is the less signed that is supposed to be normalized, right? So if we click OK and we go to our page, we can see that visually it is the same, but let me just quickly stop the tamper, and behind the scenes we can see that it was transformed. What happens was it do the normalization, and then when we get to the point where we need to validate it, just let me close. Oh no, it's okay, sorry. So guys, here we do the normalization, it do the transformation into the less than sign, and then our HTML special charge was able to find it and say, I know who you are, and I'm gonna make sure that you are just an HTML entity. And therefore we saw that is not able to be executed again. Finally, let's go to our report. As usual, we have an ID so that we can follow up the resolution of this specific security control or recommendation. We said that the risk level is medium. Here, the spoofing is the threat type. Why spoofing? Because in this case, if you can steal cookies via cross-site scripting, you can impersonate end users. It's just one example. The threat description, cross-site scripting due to lack of input and output validation. As usual, you can put the line of code being affected. Then the risk analysis, so that we know the risk level, which can help us to prioritize this specific issue. High risk levels is going to tell us that needs to be fixed as soon as possible. So the impact to the organization is low. Why low? Because in this scenario, it says that it is affecting a public facing section only. That means a section which is publicly available by anyone, but that section, even if it is exploitable, it doesn't contain any sensitive information. There is no information disclosure, and therefore, I mean, there is an impact, but it's going to be low for the organization. The likelihood of exploitation is high, definitely, because as we saw, there was no input or output validation. So the resource is exposed to internet without any validation. Finally, the mitigation techniques. The corrective one, which means something that needs to be fixed as soon as possible, is in the control E.1.1. Restrict input to a specific type and size. Is always welcome to do input validation, although in cross-site scripting the most important part is the output encoding, as we saw via HTML special chars. The input validation is also very useful because it can help you to limit the attack range from the hackers. You can say, you know what, you're just allowed to put 10 characters and only numbers, for example. That's going to be more difficult for an attacker to execute it. Still possible, but more difficult. And also the recommendation to use HTML special chars with those specific options and quotes and substitute. We talk about the standard. In this case, PCI 6.5.7, which talks about cross-site scripting. And finally, the preventive actions. Obviously perform security code reviews during requirements phase, so that these kind of issues can be identified on time before moving to production, and training for the developer related to ethical hacking, so that he can understand how cross-site scripting works and other web-based vulnerabilities, and then he have more options when dealing with the solutions. See you in the later class. Okay, as promised, we have here a real vulnerability going on in the wild. Usually, Security Focus is a well-known site that provides information about all multiple vulnerabilities found in all different products and different types of issues. Here, as described by the title, it has a CVE. CVE is a vulnerability ID worldwide that it is assigned to a specific vulnerability. It is unique and it can be referred by multiple vendors. In this case, it is the 2015 4039. And it is talking about a problem in a WordPress. If you remember, WordPress is a content management system that can be used as open source so that everyone can have its own website, mainly for blogging or those kind of specific tasks. Here, there is a plugin used in WordPress. It's not a WordPress vulnerability, it's a plugin used with an stored cross-site scripting. As you remember in our class, stored cross-site scripting means that it is going to be stored into the system, most of the time into the database, and every time you visit that specific page, is going to be executed our malicious JavaScript, VB script, or any HTML code that we enter. Obviously, stored cross-site scripting is more dangerous than just reflect cross-site scripting. Reflect is just at the moment that you provide the link, you will provide a response. Is in that specific moment. Stored is going to be there forever until the administrators remove the issue in the database. So here, by looking at the description, it says that, well, there are some problems, even there are some proof of concepts about logging as a regular user and trying to update the profile fields is one option, or the second option is also logging as a regular user and try to post a new message. When I was trying to install the plugin in our lab, I realized that you need to pay for it. As you can see here, it's $24. But since this is a well-known vulnerability, I'm not discovering it. I'm not attacking this software. It's a well-known vulnerability, and they offer a demo login. I just gave it a try. It was interesting to see in the CVE that in the solution says no official solution yet exists. So I log in with the demo user test and the password test 123456, and then I went to the all post and I can start editing one of those already posts that people added. Let's choose the first one. Here you have visual and text. If I try to enter just by testing the classical, nothing encoded, nothing obfuscated, just plain JavaScript, something like this, and I'm gonna click on update post. If we go to all post and click on the one that we just added, which is ASDF, you can see that we are executing cross-site scripting. That means the JavaScript that we put there is being executed. So let's see what we can do with this. The first thing to notice is this is called an stored cross-site scripting. And the reason of that is because if you sign out and then go back, we are signed out, right? And we come back, if we go to the all post and click on ASDF, we see that our injection is still being executed, is stored in the system and potentially in the database. That's the reason it is called stored. That means I can just inject one time and my script is gonna be run for this poor user every time he connects. But what you can do with this, okay, first of all, let me show you something interesting. If we come here, we have our script, but we didn't get a pop-up right here, as you notice. If we go to the page source and look for hi there, which is right here, you can see that in this specific edit mode, the system was able to put what it is called encoding HTML, which means it is changing the less than with the HTML version, and therefore is not being executed as a JavaScript code. It's just treated as a text. And then we can see it, the content in our page as it is, but behind the scenes it is being treated as text. That's the reason that here we are not getting any pop-up. But if we try to see the post, you see that we get the hi there. If we see the page source here, look at that. There is no HTML encoding at all. We have the plain script and therefore it's being executed. It's very interesting to see that even though they know how to fix it and they did it, they forgot to put the same security control in a different section of the page. So let's see what we can do with this, which is a real scenario for attackers. The first thing the attacker is going to try to do, well, not the first thing, I mean, one of the things is to steal the cookies. We can get the cookies by doing document.cookie. In a real attack, the attacker is not going to print the cookie. It's going to send the cookie hiddenly to his site so that he can reuse it and impersonate that specific user. Let's see if this works. When we click here, look at that. We get all the session cookie, WordPress test cookie for that specific user. As I said, if you get this and open it in a different PC with a different browser and just create this cookie with the same parameters and values, you will impersonate that user in a real scenario. What else the attacker can do? Well, as you know, one of the most important campaigns by hackers is to send you social engineering emails, which means they are trying to convince you to click on specific URLs so that you can go and get infected. In this case with cross-site scripting, that's pretty easy because you can force the browser to open up a page for you. Again, I'm gonna do it here, this, so that we can notice it, but in a real scenario, the attacker commonly is gonna open a iframe. With the iframe, the end user or the victim is not gonna be able to even see that it is being connected to another site. So let's do this in JavaScript. We upload the post, we go to all post, click in our thing, and you can see that we were redirected to Google. Again, in a real scenario, this would have been hidden to the end user. You can do multiple things, anything that you can imagine, as an attacker. Another well-known attack is, for example, to enter a phishing page. Let's say that you wanna trick the users thinking that they were logged out. So we put HTML code. Please re-log in. And then we can put here our code. We can say username, here, and then we put our input text, input type equal text, name whatever, and then we can put this is 1, and then we can do exactly the same, but for the password field, so we put a different name here, name B, and then we say here is the password. Okay, so we save this page, and then we go to all post, click here, and you can see it says, hey, please relog in with the username and password. This can be used also to gather actually not only the cookie session but the real password from the victim. This is kind of a phishing related attack. As I said, multiple things. The final example that I can show you is if you want to send a message like Anonymous or those guys, activists, hacker activists, that they just want to send a message saying, hey, we don't like the way you act, or we are forcing you to take down that specific website because otherwise, you know, any kind of intimidation, or just a message to the administrators. That's another thing. It's like the scary part of this. That can be also possible because we have control of this. I find this really cool image, which is just an example. You can just put it here in the source and you're good to go. We save it, we go to all post and click here, and we got our picture displayed in the main page. So you can see that this is a real vulnerability, pretty easy to exploit, and with really bad impact to the end users. Keep in mind that these kind of attacks are focusing on the end users, since all this exploitation is being done in the browser. Fortunately, there are multiple browsers that supports protection of cross-site scripting. And that's the end of it. Hope you enjoyed.